So this is part 2 of lesson 3.2, solving systems algebraically, and in this lesson we're going to be talking about the elimination method. I have a list of things you can do to use the elimination method, and we will refer back to this. The idea is, and I'll just try to write it real quickly here, the idea is to end up with two of your terms to have either the exact same coefficient. So I'm looking at y here. This has a negative 8y and a negative 8y. So to have the same coefficient or opposites. So since I made up these equations, I'm just going to change it. So here they have the same. They both have a negative 8y. Or you want them to have exact opposites, an 8y and a negative 8y. And actually this is the easier scenario if you can get them to have opposites. So that is our goal. The reason that's our goal is because now, remember, these equals mean they're the exact same value. So 6x plus 8y equals 13. 3x minus 8y equals 11. We can add and subtract the same value to both sides of an equation. Like over here, I could add 8 to both sides and add 8 to both sides. Well, this is the same as this. So I can add 3x minus 8y to this side and 11 to this side because they're exactly the same thing because it says they're equal. And so that's going to be our goal, because if we add this circled part to the left side and 11 to the right side, look what will happen. We'll get 6x plus 3x is 9x. 8y plus negative 8y is 0y. And then 13 plus 11 is 24. And that's our goal. I'm not going to keep solving out, but this is called the elimination method because we just eliminated one of the variables that was involved in both equations. So that's the idea behind the elimination method. The thing is, they're not always set up like this where they're opposites, an 8y and a negative 8y. So sometimes we have to do something in order to get them to look that way. And that's what we have here in our steps. If necessary, multiply both sides of one or both equations so the coefficients of the variables to be eliminated have the same absolute value. So having the same absolute value means they're either the same thing, like a negative 2 and a negative 2, or a negative 2 and a positive 2. So in this case, they wouldn't need this because they already are opposites. Add or subtract the equations to eliminate one variable. Well, in this case, we just added because they were opposites. If they're the same sign, we would subtract. Solve the resulting equation for the remaining variable. So we got here, we would have solved this equation by dividing by 9. If the signs before the variable to be eliminated are different, add the equations. Okay, so that's what we just mentioned. If they're different, which this was positive and this was negative, you add. If they're the same, you subtract one from the other. Once you find that, now this is one I just made up, so we divide both sides by 9. X equals 24 divided by 9 can reduce by 3. You get 8/3. So once we finish step 3, we're actually kind of back to substitution property. X equals 8/3. We could take 8/3 and plug it back to either one of these equations to find the remaining y value. So you write your solution as an ordered pair. We talked about this when talking about graphing, but here's again, if you have one solution, so if you actually got a solution, it's consistent independent. If you get a statement that's always true, so you might do elimination and get down to 7 equals 7. Well, that's true. Or right here it says 3 equals 3. That's actually when your two equations represent the same line, and so there's an infinite number of solutions, so it's consistent dependent. And then if you get to something that's false, if you do elimination and get 2 equals 9, well, we know 2 does not equal 9. That's something that's false. So if you get down to something false, there's no solution, which means graphically, if we were to graph them, you would have had parallel lines. And then last, you can check your solutions by by plugging it back into the equation. So let's try some elimination. And maybe I'll be flipping back and forth to this screen to help us think through this. All right, so up here in the first one, we actually could use substitution to solve this because all these coefficients are 1 or -1, but we're talking about elimination, so let's do elimination. So what we're looking for is either the same coefficient or opposite coefficients. Opposite is usually easier. So this is a coefficient of 1, 1, 1, and -1. Well, these are opposites already. So if you have opposites, so first of all, it's not necessary to do this first part because they already have the same absolute value. And we actually like this because the signs are different. So let's come here. Signs are different, so we can just actually add. Remember, x minus y equals 10. They are the same thing. X minus y is the same as 10, so we can add x minus y to this side, and we can add 10 to this side. So watch this. We're going to add here. I'm adding because these signs are opposite. X plus x is 2x. Y plus -y is 0. We just eliminated the y variable, and 4 plus 10 is 14. Divide both sides by 2. We get x equals 7. Now, we're not finished. We have to go back and find y, so we can plug this back into either one of these original equations. Let's pick the second one just for fun. We have 7 for x, so x minus y equals 10. So 7, because x equals 7, minus y equals 10. Subtract 7 from both sides. We get -y equals 3. Divide both sides by -1, and y equals -3. It would be just as easy, or easier, actually, to plug it in here. Plug the 7 in here, because we have 7 plus y equals 4, and y would have to equal -3. So our answer is 7, -3, and since we mentioned it, these, or this, we got to an answer, and so if we get a solution, this is consistent, independent. Consistent because there is at least one solution. Independent because there is a countable number of solutions. There's just one. So our answer is 7, -3. Going to the next one. 3x plus 2y equals 8. 3x plus 5y equals 14. Looking at this, as we start working with elimination, this should pop out to us. We have a 3x and a 3x. That's a good thing. Coming back here, if necessary, multiply both sides of one or both equations so that the coefficients of the variable to be eliminated have the same absolute value. Well, we already have that same absolute value. We already have them to be 3x. They're both 3x. And so what do? Well, we want to eliminate. So how can we work with a 3x and a 3x to eliminate? Well, we subtract. So we're going to subtract here. So 3x, and we have to be careful here. I'm going to put parentheses here because we're subtracting this whole thing. 3x minus 3x is 0, so they eliminated. Be careful here. It's 2y minus 5y. 2y minus 5y is -3y. 8 minus, should put a negative out here, 8 minus 14 is -6. We can solve for y by dividing by -3. And we get y equals -6 divided by -3 is 2. We got part of our solution. Now we can go back and plug into either equation. Let's do the first one. So we're going to take 3x. So I'm using this equation right here. 3x plus 2y, but we just solved for y and it was 2. So I'm putting a 2 in here. Equals 8. 3x plus 4 is equal to 8. Subtract 4 from both sides. So we're not just solving a nice easy equation. 3x is equal to 4. Divide both sides by 3. And we get x equals 4/3. 3. And so our answer is an ordered pair again, 4/3, 2. Same thing, it's consistent, independent. We got a solution. There was only one solution. There is a solution, so it's consistent. It's one solution, so it's independent. Last couple examples here. This left one, again, we're looking at our coefficients. We have a 4x and an 8x, and a negative 2y and a 2y. Well, this works out really nice for the y's. The x's aren't too bad, but for the y's here, they're opposites. We have a negative 2y and a positive 2y. So how could we eliminate the y's? Would we add these together or subtract here? Well, we would add because we already have opposite signs. So we're going to add 4x plus 8x is 12x. Negative 2y plus 2y is 0. They eliminated. And 13 plus 23 is 36. Divide both sides by 12, you get x is equal to 3. And now we take that 3 and put it into either one of the originals. Let's pick the top one. So we have 4x. We just found doing top one. X is 3, so 4 times 3 minus 2y is equal to 13. 4 times 3 is 12. So I'll go ahead and subtract 12 from both sides. Negative 2y is equal to 1. And divide both sides by negative 2. Y equals negative 1/2. And so our solution is 3, negative 1/2. Still consistent, independent. All right, now we get down to this last one. And this last one, we finally get to do this first step that's here, because when we go back and look at it, we notice these things don't have the same absolute value. So looking here, we have a 2x and a 3x. Well, they're not the same. We have a 3y and a negative 2y. They're not the same or exactly opposite. So we have to do something with this. And so we have to multiply, we have to pick one or both equations and multiply both sides of this one by something and both sides of this one by something. So this is where we do some thinking. This one's not too hard. So I'm actually going to pick the y's. I like to choose the y's because their signs are opposite, and I like when the signs are opposite. But they're not the same number. This is a 3 and this is a 2. So what we think is, what does 3 and 2 both go into? Or the least common multiple of 3 and 2? Well, 6. 3 goes into 6 and 2 goes into 6. And so we want these to be 6's. So we think, well, how do we get the top one to be 6? How do we get this 3 to be a 6? We're going to multiply both sides by something. Well, to get 3 to be a 6, we multiply by 2. So multiplying by 2 gives us 4x plus 6y equals 12. How do we get this bottom one to be a 6, or actually a negative 6, because we like opposites? Well, 2 times 3 gives me 6, so I'm going to multiply both sides by 3. It doesn't always work out that this was a 2, so we multiply by 2. This is a 3, so we multiply by 3. It actually does always work, but sometimes there's a smaller number that works. So multiplying, we get 9x minus 6y is equal to 8 times 3 is 24. And now that we're here, look what we have. We have a 6y and a negative 6y, so we can combine those. We can add them together, and they'll eliminate. So 4x plus 9x is 13x. 6y minus 6y is 0. That eliminated, and that's what we wanted, equals 12 plus 24 is 36. Dividing both sides by 13, we get 36/13. That doesn't go into there. So there's x. And here's something you can do. And we can take x and we could plug it back into one of these. This is a 36/13, which isn't a real nice number to work with. So we can actually eliminate again if we want to. So first of all, let's stick with what I said before. Let's now plug this back in. I'm going to put it in my first equation here. 2 times x, which is 36/13, plus 3y equals 6. Multiply here. Well, this is 2 over 1. 2 times 36 is 72/13 plus 3y equals 6. We're going to subtract 72/13 from both sides. All doable, just fractions, so it makes things a little messy. So in order to subtract here, to subtract 6 minus 72/13, this is 13th, so we need to get a common denominator. So this is a 6 over 1, so we can multiply by 13 over 13. Well, 6 times 13 is 78. So this is actually 78/13 minus 72/13, which is 6/13. So we got a common denominator, 78/13. 78/13 minus 72/13 is 6/13. Once we're dealing with fractions, we can divide, but I always like to say it's easier to multiply by the reciprocal. So multiply by 1/3. Over here it cancels. In fact, 3 goes into 3 once, 3 goes into 6 twice, and we get our answer of y is 2/13. So a pretty messy answer. 2/13. Sorry, our x is 36/13, and y is 2/13. Now, what I was mentioning earlier is once we found this, we could have actually come back to our original equation and eliminated the x's, and that would have helped us find y. It would have been a lot nicer than plugging in and having to work with common denominators and stuff. So let's do that really quickly. 2x plus 3y equals 6. So again, just to let you know, this is an alternative to plugging 36/13 back in for x. This is another way to find y. So 3x minus 2y equals 8. All I'm doing is rewriting my original. I eliminated y's before to find x. Now let's eliminate x's. I'm going to go through this a little quicker because I've taken up a lot of your time already. In this case, we have a 2x and a 3x. Well, we talked before, 6 is the common multiple. So we can multiply the top by 3, which I'm going to put here. So we get 6x. I'm going to distribute here, 6x plus 9y equals, sorry, I forgot to put 3 here, equals 18. The bottom here, I'm going to multiply by not 2, because that would give me 6, but negative 2, because remember, I like opposites. I want to have opposites here. And so we have negative 2. We're going to distribute this. This will give us negative 6x plus 4y, because I distribute the negative 2, equals negative 16. And now with these two, we can simply add together because we have a 6x and a negative 6x. That eliminates. We have 13y is equal to 18 plus negative 16 is 2. Divide both sides by 13. And we get that y equals 2/13. So in my opinion, I thought this was a little easier than plugging back in, working with the 72/13, getting common denominator, and solving. I just went back and eliminated the x's this time and still got that 2/13 for y. So there's our answer. That is the idea of the elimination method for solving systems of equations.